Okay, this is a lightning talk called Code or Die. We're at PyData Warsaw. It's Friday, October 10th, 2017. I'm James Powell. If you like this talk, you can follow me on Twitter at Don'tUseThisCode. This is a talk about a hobby project that I've been working on over the past few weeks. And as many of you know, hobby projects are a big distraction. In fact, one of the best things about hobby projects is that they can be very distracting. So before I tell you about Code or Die, I want to tell you about a couple of things that distracted me from doing the hobby project that has been distracting me from doing actual real work. The first one is a library that I've written called PG-SQL Parse. Most of the things that I'll show you in this talk are about 50 to 70% done, so just wait a little bit before they're ready to use. PG-SQL Parse is built on a library called libpgquery, which is an extraction of the query engine, the parser from Postgres itself. And so what I can do in Python is I can take string SQL, I can parse it into a Python AST, or rather into a Python representation of the SQL AST, and I do neat things like I can look at the where clause, I can take another piece of SQL and I can merge them. So in this block of code here, I'm taking this query and I'm sticking it under this common table expression, which is kind of neat to be able to do in a systematic fashion. Now that doesn't seem very useful. So the reason that this was the lowest level of the hobby project is because I needed this in order to do another hobby project called Gormless. And it's kind of a weird name. I'll explain the name to you really quickly. I wanted to create an ORM for use with Postgres, but I hate ORMs, so I wanted to create like an anti-ORM. And that's, you could call it like PG ORMless, or in other words, Gormless. In English, Gormless means kind of stupid. And this is essentially a pretty stupid idea. What I have is I have a way to map arbitrary SQL to the Python object model, to Python methods and Python descriptors. So here you can see some base object, and you can look it up by ID, by name. You can do inserts and deletes. Here you have some object that represents a ship. You'll see why I call this ship later. And it has some fields like a speed, location. There are some, it's all kind of like an uglier version of a normal ORM, where I have some foreign keys, I have some normal fields that are just properties, and I have some other methods. Well, the neat thing I can do is I can do this. I can select from the database and get a Python object out. So this thing ship here is not a tuple, it's not anything else, it's an actual raw Python object. And when I have a Python object, I can also do things like ship.byId and pull it out by ID instead of using a raw query. But once I have a Python object, I can do things like ship.location, and it'll give me another Python object representing the location of this ship and whatever that might mean. Once I can do that, I can do neat things. I can say ship.location.nearby ships to find all the ships that happen to be nearby that one, where this is a Python property, this is a Python property, and it corresponds to a couple of SQL lookups against my database itself. The interesting thing is I can then arbitrarily add adapters on top of that. So here, ship.allnames is all the different names that might refer to this ship. Notice this is just a property lookup. This gives you a Python dictionary that has its insert and removal methods overridden. So when I do something like this, I do a set item on the dictionary, it actually goes and updates the database. When I do a del item on the dictionary, that also corresponds to a database operation. Most ORMs don't give you any of this. They only give you a mechanism to interact with the database via functions, not via arbitrary Python syntax. This is an actual Python dictionary that whenever you perform an operation on it, it transparently updates the database behind the scenes. One neat thing I can do is if you look closely here, there was this little thing called notifications. Well, I can start a separate thread so that if another process completely separate from mine updates the object in the database, I get a notification in my Python process and it transparently updates the database. So this ship object here is always up to date with the current state of the database or whatever notifications I've received. So I can have multiple scripts running against this database and I never have to worry about reloading something because they're being transparently reloaded by a thread in the background. That's kind of cool. I can also do something really neat, which is I can set context on my cursor. So I can create a common table expression like this, and then that applies itself using my AST parser against every operation that occurs under that context manager. So this ship.location.nearbyships.homeworld.nearby ships is a bunch of SQL lookups, each of which is now being wrapped in this common table expression. That's why it was useful to have that tool. So even this update operation that looks like just a raw string is actually being wrapped in that common table expression, which is very useful for now doing very complex lookups against the database and transforming them into single SQL statements. Very efficient ones. I can also create arbitrary queries. So here's a definition for a query. I select some from and some to from some database. Here are the parameters I pass it. I give it a graph adapter so that I can now select things out of my database and turn them into NetworkX graphs. Most ORMs give you one table row equals one object. My ORM is not really an ORM. It's just an arbitrary mapping of SQL to the Python data model. So I can take subsets of tables and turn them into NetworkX graphs. No other ORM can do anything close to that. Similarly, if I did something like scores, here, I can give it an array adapter, and I can select subsets of my database, subsets of rows in my database, and transparently stick it into a NumPy ND array. And when you update that NumPy ND array, it transparently updates the database contents itself. Nobody else can do that. Why? Because who cares, right? Well, I came up with an idea for a game. Many of you have played the game Risk. It looks kind of like this. And I thought, what if we took the game Risk and we set it in space, we added spaceships, solar systems, neat things like that, because we don't want to be sued for copyright infringement. We make it a real-time game. We take away the game board and the game pieces entirely, and we replace them with the JSON API. So using a tool, HTTP, I could give any arbitrary semi-technical user this command, and they could kind of figure out what it does. It's an HTTP request. I get all the systems. You can probably kind of guess what that does, even if you don't know a lot about JSON APIs, even if you don't know a lot about the command line or about Python. You can guess what this does. It gets all the ships. You could guess what this probably does. It gets the system number 32. You could probably guess what this does. It puts an order on ship number 12 and tells it to move to some destination. It's a very simple, very low-level JSON API. What I could do is I could give players of this game a simple handout with curl commands, and they could play the game by just manually writing those curl commands in the console. Anyone could play this game. And what they do is they'd start with something as simple as this that I wrote for them, and they'd start kind of playing around with the parameters. They'd say, oh, 12 to 23, oh, that moves ship 23, not ship 12. Going from this moves it from Mars to Venus. Well, interestingly enough, for the first 30 minutes of the game, people could move about 10 ships around with just manual API calls. It would be really tedious. But what if I scaled up the game to 100 ships? Then you'd have to write a bash script. So the newbie will have to come to me and say, well, how do I do these commands in a loop? Because I can't type these fast enough to compete in the game. And you tell them, well, this is how you write a simple bash script. And as they write more and more complex bash scripts, they'll say, this sucks. So what are they going to do? They're going to write Python scripts. The API output is JSON. That looks something like this. You're going to get bug-eyed if you look at this too closely. And the newbie's going to say, I cannot interpret these results quickly enough to play the game. And you're going to tell them, well, why don't you write a report using Python? Here, I'll teach you about f-strings. I'll teach you about the request library. I'll teach you about all the things you need to be competitive in the game. Maybe you could even write a web front end, so I'll teach you about Django and Flask. And that might help you play the game and win against your friends. What happens when there's hundreds of ships moving in real time? Even if you had scripts and a JSON API, even if you had a meta API and scripts and things like that, you won't be able to compete. So what are you going to have to do? You're going to have to write a bot. You're going to have to use simple AI techniques in order to compete in the game. I like this game because you start very simple and you can get arbitrarily complex, driven by the desire of the players to be competitive at the game. Even newbies can play by just copying and pasting commands to their terminal. But they will, through natural motivation of wanting to be competitive in this game, come to you and say, how do I get better? Teach me more about programming. I need to know how to do this. Tie this explicit, tangible goal that I have in playing the game to some arbitrary, abstract piece of programming knowledge. It is a very strong motivation to learn programming and to improve your programming, because the worse your code is, the worse your performance in the game will be. I like this also because it's an approach to programming via automation. And in the automation view, perfect code doesn't matter. The only thing that matters in this game, it's not perfect code, it's not writing the best code, it's about competing, it's about galactic domination. So that's Code or Die. The rules are on GitHub. The other two libraries will be posted to GitHub once they're a little bit closer to complete. I hope to talk about this game more next year when it's fully developed. The API is going to be very simple, and the whole goal is, how do we take somebody who wants to program but who finds most materials for programming too simple, and not too simple, but too abstract, too detached from the actual task they want to do, and to make the motivations very clear, very obvious, and to drive the learning from the perspective of the learner trying to do something very specific, like, how do I compete? How do I beat my friend? How do I move my ships fast enough? How do I do this in a loop? I really like this idea. It's something I'll be working on more in 2018. I hope some of you might be interested in contributing. Thank you.